Hi, I'm Tom Stephenson and welcome to Construction Job Site Management. This is lecture 3A of two lectures, 3A and 3B, which will be fundamentally based on chapter 4 of your Construction Job Site Management textbook. And we're going to be reviewing today the areas of submittals, samples, mock-ups, and shop drawings. So as I said, it'll be broken up into two parts, and we'll be in the first part looking at submittals, what are they, looking at types and examples of submittals. We'll be looking at mock-ups, shop drawings, sampling, really why do we do that and what's kind of involved in the process. And then in the second video, we'll be looking at, well, how do we monitor this? How do we control this? And because it's very time intensive and it's a requirement to be successful in construction. We want to make sure that we're doing the right things, and we want to make sure that whoever's our suppliers, manufacturers, installers, they have the most in-depth, correct drawings for what it is that they want to do. So we'll get into it. So when we think about the construction documents, as you recall from the previous lectures, there's the project manual, and as part of the project documents we have all of this information here that we utilize, RFPs, requests for proposals, instructions to bidders, the bid forms, general conditions of what's in the contract, any specific supplementary conditions that we are specifying for the contract, any additional information bidders might need, and then we got into the specifications and what's required in the specifications and the formats they use. We talked about the 16 division format and the 50 division, 0 to 49 divisions. And your textbook might say 4 to 48, but that's because 49 is just a reserved section. Okay, and then we have the drawings. Look at all the different types of drawings that we may be involved with. Most we will be involved with as part of the project requirements. And any kind of commercial project, you're going to have individual structural drawings, mechanical drawings, electrical engineering drawings, special construction information. This all becomes part and parcel together with the specifications and the contract of the project manual. So today, as we mentioned, we're going to be looking at submittals, and we're going to be talking about shop drawings, material data, samples, and the sample submittal process, which we'll get into in lecture 3B. So types of submittals. Well, basically the product data submittal consists of the manufacturer's product information. Architects and consultants, they'll specify something, but with a certain intent. And then it's up to you, the GC, to sort of make sure that this product is going to meet that intent. So you gather the information from the supplier you're going to use, and they will provide you data, and then you submit that to the consultant to review and to make sure it's in alignment with what the intent was in the drawings and specifications, so that you don't go ahead and order something and then it's not in alignment with what the specifications and drawings intended. So it'll of course have the manufacturer's name, trade name, model number, use and performance characteristics. If you're talking, say, about paint or additives to concrete, it could be a lot of those kind of things. Size and physical characteristics, where that's important. Finish characteristics, where that would be important if it's a finished material that would be visible after construction. And a lot of the process involves a little bit of back and forth too, with specific requests for job site dimensions. Before somebody fabricates something, they want to make sure it's going to fit, so they want to have the data in place that it will fit. Now, the world is changing a lot, as we've mentioned, and we are moving to more and more BIM models, and there's more and more high quality scanning technology that can really ensure that our dimensions are much more accurate than they have been in the past. So our processes for submittals are also evolving to better represent these changes that are going on in the marketplace. So shop drawings, really a shop drawing, it's the manufacturer's intent of how their product is to be installed. So, for example, if we talk about a house, the manufacturer for the roof trusses, they will do shop drawings for the roof trusses, and it'll show the strength characteristics of the trusses. It'll show basically where the webs are supposed to be located, the size of the cords. It'll indicate the calculations for the snow loads that it's capable of carrying, and it'll show and indicate how it is to be placed on the roof and where it is to be placed on the roof, and the fasteners that are to be used for it to ensure that it complies and that it has the capacity to carry the loads in practice. Now, an architect would not be able to come up with that information, or a structural engineer would not be able to come up with that detailed of information that the actual manufacturer is going to use. The manufacturer is taking the engineer's requirements. They're also making sure that it complies with the building code, and then they're putting that together to make sure that their product will comply with building code regulations, and hopefully it'll comply with the intent that the engineer had for that particular product. In case of my example, roof trusses, we call them truss drawings. That's the thing in residential construction. You probably don't hear shop drawings that much, but they're there. They're just called what they are: truss drawings, manufactured floor drawings, kitchen cabinet drawings, kitchen cabinetry. You know, the designer shows the kitchen cabinet layout in the floor plans, but then when you actually go to buy the cabinets, there's a lot of more detail that's required. You know, where are you putting the drawer banks? Which ways are the doors going to open? Exact sizing of the cabinets that is going to fit in that location have to be verified before they go into production. Those kind of aspects are done in the shop drawings. In commercial projects, you have shop drawings for things like the reinforced concrete. So the structural engineering drawings will show the rebar layouts, how the rebar is supposed to be placed, the size of rebar. The shop drawings from the rebar supplier, they will show the rebar and how it's going to be placed, and tags and tag numbers for the rebar, so that when it comes off the truck, you know what rebar is for where. Otherwise, you get it very confused and you wouldn't know which rebar goes where, etc. So they try to have it, make it very easy for the actual laborers that are installing the rebar to be able to infer that information and then install it properly. But they better have taken the information from the structural engineer and done it right. And the structural engineer, before it goes into place, wants to review it and make sure there's not been some error or something of that nature. So that saves a lot of trouble in the construction process later on. So we can think of that from the shop drawings perspective. So it has more detail in that sense because it's really that manufacturer, what their intent is as far as the installation process goes. And you're supposed to install it how that manufacturer has indicated, or that manufacturer is not going to take any responsibility for anything too. You know, you get the roof trusses from the roof truss supplier, and then you don't go install it. You use brackets or hangers that are supplied by somebody else, and they don't have the same structural strength. Well, they're not going to warranty that or be responsible for that because you didn't follow their instructions for the installation. So it is kind of a series of checks and balances that are put in place to make sure that we have compliance with, as I said, the intent of the overall drawings and specifications and project manual of the project, but really the specifications and the drawings. So information includes comparison information, comparison between the drawings and the structural drawings that the engineer perhaps drew, if we're talking structural stuff. Notes of changes or alterations, information needed for fabrication, so what they will require from the contractor so that they can go into fabrication. Nothing gets fabricated until the shop drawings have been reviewed. Dimensions needed for verification, placement or installation information, and perhaps samples. Depends what it is, right? And we'll get into the sample aspect. So shop drawings, so the comparison information should compare and be related to the specs and drawings, as I mentioned, should address appearance, performance, prescriptive descriptions. Again, you'll find a lot of that in the specifications, often more detailed than the information on the drawings from the architect or engineer, as I mentioned, and can review fabricators' version of the product, so they can actually see their version of the product. So the architect and engineer, they know it conceptually, they know the intent, and from the structural point of view, they would know the structural requirements, but they wouldn't get into as detail as the shop drawings typically will. Manufacturer's material information, anything specific that this manufacturer needs to inform the architect or engineer on their product. And it should be very clear and complete. You don't want to have stuff missed, because this slows down the process, because there's a review process that's involved. Notes of changes or alterations. If there's changes from the architect engineer's design, they should be noted. So that way it highlights if there's something that can't be done, then what's being done instead. Very often this is the case. The consultant doesn't know that this particular supplier is unable to do this particular thing, but they have a workaround for it. So it should be highlighted, so when they're reviewing it, they clearly see it. So doesn't slip by and it's missed. At the highest level, the architect and engineer are responsible for any changes to the review. But this does get complicated when we talk about legal cases. My best friend is a judge. I've run with him for many, many years. And trust me, in that time, I've had a lot of time to ask a lot of questions. My daughter's now a lawyer, so I can ask her lots of questions, and I do. And I could probably sum up in 2 words what they really generally tell me, especially my judge friend. So he'll usually say, well, Tom, it depends. And what he's really saying with the it depends, he's saying it depends on the documentation, depends on the evidence, right? So there's no one answer. It depends what the evidence is saying, and they interpret that evidence, and then they make decisions on that. So, if an architect misses something or an engineer misses something on the review documents, but it was kind of hidden in the review documents and it should have been sort of pointed out that this is a definite change, then it depends. It depends how that's presented, how it was shown to the design person, how maybe it would have been easy for them to miss and it should have been highlighted, not buried in the document. So these are some areas that, it's gray areas that you have to be cognizant of and careful about. So there's this old saying, he or she who has the best paperwork wins. There's a lot of truth in it. And believe me, in construction, doing your due diligence in making sure that the documents are carefully reviewed, that you review them. Maybe you see something that the architect maybe missed. Well, let them know. If you need some extra information, that's what an RFI is, request for information. And it's documenting it. It's not just verbalizing it. So shop drawings are helping to clarify things, that if there is something that's a little different, here it is. And so now when you're actually installing it, it's been reviewed by the engineer and the architect and it's been okayed. They don't approve. That's another thing. They'll typically say reviewed. They reviewed it. Again, there it gets into legal implications. I approved it. It's a little bit more holding them accountable. So they're kind of careful about that. In the book, and I think in one of my slides, one of them says approved. Typically, it's going to say reviewed. Information needed to fabricate the product. So dimensions, I should say needed there. Dimensions, manufacturing methodologies to work on site, special fabrication instructions, as I said. Fabrication drawings should include everything that the fabricator needs to manufacture the product. So all the information needs to be there. So fabricating is different than your drawings. It's got to be more detailed, because the fabricator has to put all the components and pieces together to make whatever the assembly is that then goes into the building. Indication of dimensions needing verification. So anything that needs to be verified. Look, when you have a set of floor plans and you build the building and it says it should be 25 5 foot 6.5 inches. You know what? It might be end up being 25 foot 5 3/4 inches. There's tolerance variances. So what kind of tolerances are you working within? And so this is what it's supposed to be, and this is what it actually is. So there's always variation, and that would be in our tolerances. So what's the highest upper level of tolerance? What's the lower level of tolerance? And then we should be in compliance with that variation. But the fabricator wants to know what the actual is. And then even when they make it, they may have some variations in how they've manufactured it. Especially on in situ construction, on-site construction, there are always slight variations and deviations. And as we move forward with BIM, the verification of this becomes easier with scanning technologies, etc. But we still have variations. Nothing is perfect. Kitchens allow for scribes, leg adjustments. You know, you renovate a house, everything is out of level, out of plumb, out of square. Now, a new building shouldn't be like an old house is, but there still are tolerance variations. In precast concrete, facades that we put on the outside of buildings, like curtain walls, they have gravity connections that take the weight of the panel, and they also have adjustments on it so that they can adjust it a little bit up or down. They have lateral adjustments so they can adjust it in or out. To satisfy those tolerances, but the building has to be within certain tolerance levels, and if it's outside that, there's going to be problems. It doesn't have enough flexibility to adjust that much. There's room for some adjustment, but there's limitations. So panel to panel connection too, so they can make adjustments. Even the building code, look at this. This is from the Ontario Building Code. I took this out. Uniformity and tolerance for risers and treads. Tread runs and risers on stairs should be uniform, equal. Well, what does that mean? Equal. Like perfect? Nothing is perfect, as I said. However, a maximum tolerance is permitted. 5 millimeters between adjacent treads or landing. That's pretty good. That's 1/4 of an inch almost. 10 millimeters between the tallest and shortest risers in a flight. And a riser is from the top of tread to top of tread, right? Or bottom of tread to bottom of tread. It's the same thing. So from top of tread to top of tread, that's a riser. So you've got some flexibility, and that's good too. You know, if you built the stairs and you have it being inspected, then the inspector says, oh, they're out. Well, how much are they out? They're out 3 millimeters. You could say, well, actually within the code, it's 5 millimeters, so we're good. Or it could be the building code says 5 millimeters, but the specification says 3 millimeters. So watch for that, right? So if the specification says 3 millimeters, then that's what you're held accountable to. The building code, remember, is the minimum standard before it's illegal. It's not this fantastic standard. It's just the minimum standard before it's illegal. So you'd have to be careful about that. I use that as an example, and actually on the LRT in Ottawa, there was some issues with some of the stairs that they were out of tolerance. So it caused a lot of rework and grief later on in that particular example, where there was tolerances that were falling outside what was acceptable. So you have to be very careful about that, because that can be enforced. And you want to make sure you know what they are, and you want to make sure somebody's not enforcing something that's not right either. So that's the other issue. If they're telling you, oh, well, you're going to have to fix these because they're 6 millimeters out. If the tolerance was 7 millimeters, then you wouldn't have to, unless the building code said something different. Then you still have to. It's a different inspector. Placement or installation information, special anchors, fasteners, embedded brackets, adhesives. They'll include those types of things. So I think I've got some examples on embedded brackets coming up with my curtain wall example. So the curtain wall example here, this is showing where you would have some of your support brackets and your lateral adjustment brackets for the curtain wall. So curtain wall, remember, is like precast concrete slabs with window openings that can form the outside walls of exterior buildings. We see a lot of glazed curtain walls in the city with condominium buildings, but some of those condominiums have precast concrete curtain walls. In that case, they would have these adjustments. You see precast concrete done on a lot of box stores like Home Depot, Canadian Tire, those kind of things as well. And so they require shop drawings from the precast manufacturer, and those are going to show where your fasteners are going to be, your load-bearing connecting points, and your lateral connecting points. And then those are basically your load-bearing connector points and your lateral connector points. These are your joining connections between the pre-slab panels, right? So this is carrying the weight, but it can also be adjusted slightly, and this can be adjusted in and out. So again, if your slabs are a little out, you got a little bit of adjustment this way, and you can adjust a little bit this way. And these connection points have to be able to support, in some cases it might be 8,000 pounds of concrete the precast slab might weigh, that it's supporting, transferring that weight onto the slabs. And of course the slabs have to be designed to be able to support that load and transfer that to the shear walls and the columns, etc., right down through the building to your footings. And of course going back to soil capacity, and then that has to be able to support that. So you might have to have embedded anchors put at those particular points in your slab. So you'd have to have these shop drawings done ahead of when your slabs are poured, so you make sure that the anchors are embedded in the slabs so that then they will line up and then they can support the curtain walls, the precast curtain walls. So you start to see how these elements fit together. Like I have to have that information done and approved before I start pouring my slabs. If I don't have that, then I'm going to have a problem. And these are like packing pieces that go in between when you have to make adjustments, right? So the different packing pieces. So this is an example, just one example of the types of shop drawings that need to be done, reviewed, before you can order the precast, and also before you can pour your slabs, because then you're going to want to know all the detailed information about the placement of these anchors, so that they'll be able to support the direct loads from the panels. There may be also other installation considerations, and there may have to be other criteria. For example, you may find that the roof assembly, the way it was designed and the way that you want to construct the building, is not able to temporarily support the precast on the roof, right? So then you might have to have the roof strengthened and shored up so that it'll be able to support the precast. It doesn't need shoring up for just its regular use, but then that might change the design. So this information goes back and forth to ensure that you're able to do the construction process. And this starts ahead of the construction. You try to get as much of this done in the pre-construction process. And as construction is going on, of course, you will have submittals for things that are further along in the construction process, like cabinetry and millwork and things of that nature that's coming maybe several years down the road. You're not doing that in pre-construction, but as the project goes along. But the sooner you're ahead on that information, the better. You don't want something like that to end up slowing down the critical path of the project. You don't want to start, not knowing where the anchors are to be placed. You don't want that to slow down the installation of your slabs and the pouring of the slabs and the superstructure, because that's on the critical path. And that'll just have a ripple effect through your whole project if you don't have that done. So of course, then there's also, even keeping to the same theme, there's samples that you have to provide. And in some cases, mock-ups. It depends what it is. Just simple rebar, you're not going to need samples for, because the consultants know what it is and they've specified what rebar it's supposed to be. So that wouldn't be an issue. But you might have samples for, you could have samples for the color of the window. So you might want a piece of the extrusion of the window that's showing, and maybe it's an anodized brown aluminum that would indicate what the color is of it. So there could be sample requests, floor samples, carpet, finishes, baseboard, crown mold, doors for cabinetry. You could keep going with this, right? This is a sample wall section. We call that a mock-up because it's not just one piece of something. Like you could have a sample for what the exposed surface of the precast is going to look like, so you'd have a good idea of the coloring. But if it's going to be going over the whole building, you might want a mock-up that's going to show you what this whole assembly is going to look like. So the precast supplier would do up this mock-up, and then they would bring it to the site. Sometimes they even put it close to the building, so the designer and the owner, they can come to the building and they can take a look and they can sort of see what it looks like on the building. I remember when they were building Humber River Hospital, they had a 2-floor mock-up just off to the left of where the superstructure of the building was, and they had it all completed so you could sort of see that and see the building. You might have to do a mock-up for in the hospital, one of the patient's rooms. So maybe off-site you build a complete patient's room, finishes everything, floor, and then the client comes and they look at it. Maybe they don't like something about the floor finish. Maybe they don't like the color of the paint. Maybe they don't like the level of finish that you put on the drywall. Well, that's okay. Then you get that feedback information, you adjust it, you fix the mock-up, and then they look at it again, and then they like it. Then all you got to do is do the 1,000 patient rooms in that hospital exactly the same. You know what standard was set, and they've reviewed it, and now you've got the go-ahead to do that. So it's very, very helpful. We used to do a mock-up. I remember we used to do window installations, and it's kind of a little bit of a funny story. So with it's one I like to tell because I remember it really well, good, bad, and the ugly. So we would have like 1,000 windows to do for this government agency. Take out the old windows, put in the new windows. And so we put in the new window. You always did one complete. Put one in, and so it was usually for tenant housing, and so you do one house, and they would come and check the windows. And I remember one of the inspectors said, take the stops off. So I took the stops off, and the inspector said, where's the polyurethane insulation? And I may have said this already in a previous video. If I did, forgive me, but where's the insulation, polyurethane insulation? And there and behold, I had fiberglass insulation, and it was in the specifications, as you recall. So the specifications would say polyurethane foam insulation. And back then, I didn't even know what it was because it was a new product. So it was good for having that mock-up because they caught it, and it was only that one window. So that way I got to fix that and not do it in a whole bunch of them and have to go back and fix them, because that was my fault for not understanding the specifications, not reading them really closely, and being complacent because I'd done so many previous projects the same way, and then something changed. So that's mock-ups and prototypes so that you get that passed, and then it sets the standard. You can fly with it then, and it makes it much easier. So that's kind of the intro part that I wanted to give you on the submittal process with shop drawings and samples and submittals. We're going to get into a little bit of the meat of the process. How do we control it? How do we log it? Have a procurement schedule and follow it and track it, because that's a really big deal. You want to make sure that it's not going to delay the project. You want to make sure that you're proactive on it, not reactive. And you want to hold people like the consultants and clients and owners accountable if they're the ones that are slowing your progress down and costing you money. You could perhaps make a change or a claim for a change and get some extra money if it's draining you of your profitability. So you certainly want to make sure that you're not being held accountable for something that's not your fault. So we'll get into that in Lecture 3B. Have a wonderful day. I'm Tom Stephenson signing off for now.